So good afternoon everybody, myself Acharya Vishvendra. Let's discuss a numerical based on elasticity. So for a certain material, bulk modulus is given here. Then we need to find its, the first question is compressibility. Then volume in air is this much and mass is this. Then find its density in air. Then find volume inside at a certain depth. Then we need to find volumetric strain, then percentage volumetric strain, then a fractional change in volume, then a fractional change in density, percentage change in density, and dimensional formula of compressibility. So the very first question is about compressibility. So compressibility is 1 upon bulk modulus. So the very simple explanation is compressibility is 1 by bulk modulus. So if we draw the graph will be a straight rectangular hyperbola, and for 1 upon b, if we draw graph between 1 by b, that will be a straight line. In next question we need to find density. So density is mass by volume. Substituting the values, this comes out to be the density. We have taken all the units in the SI system, so it should be well understood that all the physical quantities here are in the SI system. Then we need to find volumetric stress, which is equal to pressure. So pressure we know that is equal to P naught plus rho GH. So it will be 51 into 10 raised to power 5. Then we have strain. So bulk modulus is equal to this. Using the concept, we have strain as this. Then we have density as mass by volume. So delta D by D is minus of delta V by V over here. So from here we can calculate that delta D by D will be delta Y by V, which is equal to the volumetric strain as given by this expression. Then we have to find percentage strain, so multiply this thing by 100, so you will get percentage strain. Then we need to find fractional change, it's same as delta V by V. Then we need to find density, it can be easily calculated. It can be calculated dimensions of compressibility, this is 1 by bulk modulus, so reversing the dimensions of bulk modulus gives you the dimension of compressibility. Let's move on to the next question. Next is a concept of the stress strain curve of a body and the different things in that. So let's take an example. Suppose we take a rod of certain length L and applies a certain force on it. So certainly there will be stress and there will be strain. So if we analyze experimentally the variation of stress and strain, this analysis can be represented by this graph. This is the experimental demonstration of a stress strain curve of a certain material. So we can analyze the things in terms of certain points. This is OA, BC, D and E. So you can see that in the region OA, stress is proportional to strain. So this is called the proportionality limit. In this limit,